Okay, so we're going to roll a six-sided die, and we'd like to know these probabilities. X is the outcome of the die. The first one, probability that you roll a 5 or a number greater than 3. We can call it as events A and B. What are the possible events for A? Excuse me, possible outcome. 5. So 1 out of 6 is the probability of the event. So greater than 3?
4, 5, 6.
4, 5, and 6. A intersect B, in other words, whatever that is, overlapping. 5 is common for both. So we know the total number of outcomes in the sample space is 1 out of 6. No, 6 outcomes. So A, 1 failures out of 6, so 1 out of 6 probability of A. This way you know what's happening. So what is the probability of A? It is 1 out of 6. Total number of outcomes 6. 1 favors the event A. It's a probability 1 out of 6. How about probability of B?
3%.
Probability of A and B.
6.
And those two would get cancelled, so the answer is 1/2. Well, do you believe that the events A and B are mutually exclusive?
Yes.
They're mutually exclusive.
No.
They're
Why?
not.
They can't happen at the same time.
They can't happen at the same time.
No, wait,
They can't.
never mind.
So in this case, we're actually looking for an overlap. When you look at sets and mathematical stuff, we're looking for an overlap. If it's a logical thing, we would ask, well, what is the probability that both of them would happen simultaneously? In which case, we'll say the events are mutually exclusive. Here, the events are not disjoint. So there is an overlap between A and B. In other words, this is not empty. If it is not empty, then there is an overlap. Yes.
Can you explain why you got the 1%?
This one?
No, that one.
That one?
Yes.
It is common to that and that.
Okay.
There's only 1 out of 6. Case 2, or problem 2. So once you get a good amount of practice, or if you understand, you don't have to write this stuff out. It'll come to you naturally. I'm going to do it because I'm explaining stuff. So C, the event C, how many outcomes do we have?
1,
There's 2.
2.
2, no.
No, 2 is the outcome, okay. What are the outcomes for the event D?
1, 3, and 5.
1, 3, and 5. Is there anything in common between C and D?
No.
It is an empty set. So out of the 6, 1 favors C, so 1 over 6. Out of 6, 3 of them favor D, so 3 over 6. None of them favor the intersection of C and D, 0 out of 6. So what is the answer?
4, 6. 2/3.
which is 2/3. Do you believe that C and D are disjoint? Yes. They are disjoint because they have nothing in common. They are non-overlapping. Call the events E and F. So this would equal to the probability of E plus the probability of F minus the probability of E and F. Good. What are the possible outcomes in the set E?
1, 2, 3.
1, 2, and 3. Even number.
2, 4, 6.
Do they have anything in common?
2.
2. So 1 out of 6 plus 1 out of 6 minus 2 out of 6.
Are you getting
Sorry,
1
1
out
out
of
of
6?
6 is a 0 probability.
It should be 3 out of 6.
Would it be 3 out of 6 plus 3 out of 6?
Sorry, 3 out of 6. 3 out of 6 minus 1 out of 6. 5 out of 6. Okay. So 3 outcomes in E, 3 in F. So 3 out of 6, 3 out of 6 minus 1 out of 6, 5 out of 6. Do you believe events E and F are disjoint?
They are.
Yes,
They are not.
they are not, okay. Not disjoint because you have an overlapping outcome, and that outcome is 2. Good. Okay. Now, I covered up the questions. What was the first one?
Never used.
Never used. So, what we have is we looked at 95,761 students, asked them if you've used marijuana, 60.3% said they never used, and used not in the last 30 days, used 409 days, used 10 to 29 days, and used on all 30 days. So never used it is easy, it is given in the problem itself. 60.3% or 0.603. Yeah, what is the next?
I don't know.
39.7.
I think it was like who's used marijuana.
Oh,
Randomly selecting a person who used marijuana.
it's complement.
That would simply be the complement of that event. So 1 minus the probability, you never used. Which is 0.397 or 39.7%. Between 1 and 29 days. So 1 through 9 and 10 through 29. So we are looking at the combination of those two, including 1, including 29. So we just add the probabilities. 12% plus 4%. The last one, at least one of the last 30 days. Go ahead, Hunter, and last.
No, I want to hear your rationale. I want to hear your rationale. Is it not 18.7?
Yeah, go ahead.
It's because you have at least 1 day is including all 30 days. So you have from 1 to 9 days is included. The 10 to 29 days is included. Every day is included. But since it's not in the last 30 days, it wouldn't be included. 21%.
So
18.7%.
18.7% is the correct answer. But why can I not do this? Probability of at least one is the complement of probability of none of the last 30 days. It's a conditional one. Remember, I broke this rule last time. Did I or did I?
Yeah.
I think I did. Probability at
I don't
least
think
one
you did.
was probability of none. Alex, did you say
No,
something?
nothing.
I think you were right. Go ahead.
Huh?
Someone gave the answer.
You said if you wrote the rule and I said I couldn't tell.
Oh.
You're still right.
Huh?
Was it conditional probability?
No. Oh, sorry. So. At least one. Yes.
Yeah.
What is the complement of that? Zero. My question to you is, why can I not do it this way? If I did it this way, the answer would be 1 minus 60 point, or 100 minus 60.3%. That would be 39.7%. That contradicts everything that Hunter said.
Because the events are districts.
Wrong. Hunter.
Wouldn't it be because if you're adding the well, in this situation, it's 0 or not used, so you'd be at the 81.3%.
Okay.
Double counting or.
Double counting.
Yeah.
Okay.
No.
So none of the last 30 days wouldn't simply mean never used,
No.
right? It would actually mean the combination of this as well as that, right? So the common mistake here would be the moment you see none of the last 30 days, people would simply look at never used and say 1 minus 16.3%. But if you observe the chart correctly, which I translated into this table, what is the perfect complement of at least one of the last 30 days? It would be 1 minus probability none of the last 30 days union or never used. Right. So even though this rule is great known, sometimes logic has to play a role. So this would be 1 minus adding
81.
60.3% and 21.0%.
So
81.3%, that would be 18.7.187. So
sorry.
what Hunter did is to look at it this way. In other words, the lengthier way. If you say at least one out of those 30 days, it would mean 1 or 2 or 3 or 4, etc., all the way up to 30, which would mean, but to add this, that, and that, you will get 18.7%. But I want you to remember this rule: probability of at least one is equal to 1 minus the probability of none. This particular rule is useful later on when we do distributions in chapter 4. if you took Hunter's approach in a lengthy problem, or in a problem, let's say that has 30 different outcomes, and you want to find the probability of all 30 and add them together, do you really want to do that?
No.
No, but you could do this and say 1 minus the probability of x is equal to 0. That's just one outcome, right? Or one probability that you have to look at. So in this problem, it is true that I can use 1 minus the probability of none to be equal to probability of at least 1. But you do have to keep in mind the perfect complement of that is not just none of the last 30 days, but it is none of the last 30 days union never used. Good? Because they overlap. Oh, both of them would make sense.
It's getting ridiculous.
So, all I mentioned here is that this is a contingency table. I do not say that we have to find conditional probabilities. We're not finding conditional probabilities. First off, multiplication rule has nothing to do with this problem. You know. What does all mean? To add additional, that means union. Right? Again, if you can't get it right away just by looking at the table, I urge you to write it out, don't be lazy, write it out until you become comfortable, and then you can do a shortcut. So A, union B, probability, person opposes tax, plus the probability the person is female, minus the probability of opposing tax and female. Yes? Is probability of opposing tax a marginal probability? In other words, is it a probability that you can compute along a margin?
Yeah.
Yes. 164 out of 506.
Do we need a note that's marginal?
Yes. What about female? Is it a marginal probability?
Yes.
Yes. 259 out of 506. Opposes
No.
and opposes and female. What type of probability is that?
Joint.
Joint. So opposes and female would mean that. So 65 out of 506. What do we get? As the decimal, you could give me 4 decimal places.
I left my calculator.
0.7075. Good. Here is a question. Are the two events disjoint?
Yeah.
Opposing tax
Oh, no.
and female? No. Well, because 65 of them are females and they oppose tax. So unless this is 0, we can't say that they are disjoint. So not disjoint. How about the next problem? Same approach. So probability of supporting tax plus the probability of male minus the probability supports tax and male. So supporting tax, what is the probability?
301 over.
301 over 506. Probability of a male, 247 over 506. Support, tax, and male, how many do we have? 128. Male, support. And what is that value as a decimal?
0.8300. I was 6.
Oh,
Keep running by the way.
I don't know where that came from. Thank you. What is it?
0.8300.
0.8302.
00.
And lastly, probability, person is not unsure or female. So it is the probability that you are not unsure, plus the probability that you are female, minus the probability of not unsure and female. Let's see, what is the probability of being not unsure?
65.
165.
No, 301 plus 164.
So 301 plus 164, 365.
400.
Don't just pick 41 because this 41 corresponds to unsure. We want not unsure. In other words, we want the complement of unsure, which is support or oppose. So 365.
465.
Thank you, 465 divided by 506. Female,
259.
not unsure and female.
238.
200 what?
38.
38. How did we get that? 173 plus 65. You could also use complementary rule and get the answer 259 minus 21, 238. And what is that in that?
Zero. That's all.
0.9604.
So 96.04%. So in all cases, we did not have mutually exclusive events. So this is a problem where it is better to use the phrase mutually exclusive rather than disjoint. Because we're not talking about sets or intervals, we're talking about logical statements. So if I said a person opposes tax based on the data that we have, does it mean it would exclude all females? The answer is no. The same here. If someone supports tax, does it imply that we will have to exclude all males? The answer is no, because the probability is non-zero. Same argument here, which is why we call it mutually exclusive. Two things are put together, and could they happen together, or do they exclude themselves? If they can't happen together, that probability will not be zero. Good. So, not mutually exclusive. Are we clear? Okay.